Welcome back, and today I'm going to be talking about magnetic recording. That's to say old-fashioned magnetic recording, analog recording, as in cassette tapes particularly, but perhaps reel-to-reel. I don't claim to be an expert in magnetic recording, and never really have been, but the way I became involved with it was way back in the early 1980s. This guy who used to work with me, I mentioned him before in a previous video, Archie Pettigrew at lunch table, was saying to me and quite a few other people, he said, the theory of magnetic recording is wrong, he says, and books need to be, textbooks are wrong, need to be updated, he says. He says, I'm pretty sure that, I can explain, he said, how AC biasing works without weird diagrams, he says, and I can get a much better form of magnetic recording myself, free of the hiss that you used to get in magnetic recording. You don't get that, of course, in the CDs or anything, but this is in the days of analog. And it's quite an interesting history, and I'd like to set the record straight because I've seen a few things online about him, and there's been a few articles. Archie was wasn't shy of appearing on TV, and certainly in Scotland he was on a few times about this at the time. And I got involved mainly through association because what I decided to do was to help him out. I thought this guy, was some kind of polymath or genius. Well, he was actually in electronics, certainly. And I thought that maybe I could help him and learn something about it at the same time. Just a few pictures of Archie first. Here he is. It's a wee bit later, but there he is in the pub. There's a pub in Paisley called the Wee Half, which is near the university. Although he worked in the Wee Half, in the Wee Half. It seems like he worked in the Wee Half. He worked at the university. He didn't actually wasn't a lecturer there as such. He worked in a sort of industrial sense. In fact, he really didn't like academics that much. And he kind of just put up with me, and I kind of got to like him a bit more as time progressed. But he didn't have a great great feelings about academics because he thought many of them hadn't done real work, at the bench, as he would say, and were just sort of copying from textbook to textbook, he would say. There's a bit of truth in that. I used to say about textbooks, in fact, that if it's in a textbook, he used to say it's either elementary, irrelevant, or wrong. I wonder what he'd think about my two textbooks I wrote the last 4 years or so. But anyway, there he is here. These are just friends that used to go drinking. There's no other relationship there. Here he is again, back in 2005. This is him in northeast Scotland. He drove me there when I came back from New Zealand. To say we became friends in later life. He was still working at that time. But back sometime in the 1980s, I can't even remember the time, he'd come up with this idea, and he said to me, the mechanism for magnetic recording, he says, is very simple. It's just a characteristic like y equals x cubed, a cubic. Something, he said, not exactly, but it's similar to a cubic. And I said to him, I know he had a setup in the lab, and I said, well, if that's the case, we can prove it very easily. I said, well, all we need to do is to put two sine waves in, and he agreed, something like, 300 hertz and 3 kilohertz, something like that, of known amplitudes. And if it was cubic, we would just cube this, he'd already done it anyway, algebraically or trigonometrically, and he would reduce the angles, and then we could work out exactly which frequencies occurred and which amplitudes. So we knew all the frequencies that should occur and which amplitudes. And he agreed to do this. We did it just after lunch, actually, after I think he'd said it. Didn't take very long. I had this expensive Solitron spectrum analyzer at the time. Cost at the time, I think, £20,000 or more or something. We got it through this thing called Switch to Technology, which was happened in the early 80s. I think it was called that. So anyway, we did all the measurements, and I remember plotting out the results, and all the frequencies were the right frequencies and the amplitudes were the right amplitudes. It seemed to me he was spot on correct. I mean, and I wasn't no expert in magnetic recording, but just purely from a scientific or engineering point of view, the guy was right. And he'd already been working a little bit on it, and I said, well, what are you going to do anyway? And he said, what I'm going to do is compensate for the nonlinearity using a circuit, and basically like a cube root. It wasn't quite like a cube root, a special shaping circuit. Archie didn't believe in software in those days, apart from simulations, so he didn't think a micro was the way to go, and micros weren't that great then. They were okay. And he went ahead and did it, and he produced these magnificent tapes that had, we could compare them with CDs, and the quality was very, very similar to that. And he formed his own company, Amsis Electronics, and through the university he got into it's a picture of George Cole from Minder, but that's not about him. It's actually about Archie here. Hiss-free cassettes, that is, actually will wipe out CDs. So it was about, I think, 89 or 88, or just when CDs had come in to the UK. And it says, scientists have developed a system which gives near compact disc quality for only a few pence more than an ordinary tape. And that was true. The thing that I mentioned there as well, but I wasn't really one of the inventors. I just sort of verified what he was doing, and I don't take any credit for the work that he did on magnetic recording, and I don't claim to be an expert in the area. They say scientists, of course, because in Britain they don't understand what an engineer is. I don't think to this day they know what an engineer is. So anybody that does anything technical in the UK, they call them a scientist. If it's somebody who's fixing the drains or something, repairing your TV or something, they would call them an engineer. That's how they are. He went on to win John Logie Baird Prize. I'll talk about that in a second. Here's another article. That was the Daily Mail. Here's one from the Sun. Tape that, Archie KO's compact disc. Music mad boffin Archie Pettigrew has produced a cassette tape which can wipe out compact discs. It was revealed last night. Brain box Archie has tried out his invention on amazed college students. I think it might have been before. Oh no, I think they were a university there in Paisley, only just perhaps. Yeah. He then went on to a bit of fame. I wouldn't say fortune, and that he won a John Logie Baird Prize for the tape, and he won another one for the amplitude lock loop, which I talked about earlier and will be talking about more. But here's him receiving. I'm not sure whether that might have been the amplitude lock loop one. You see, there he is there. This guy here is John Llewellyn, I think it is. Desmond Llewellyn, sorry. You might recognize him as Q from James Bond series, who did the gadget. He was invited to present the prizes, that's all. These are the other prize winners. This is him receiving one of the prizes. I don't know where he is there. But that's Margaret Baird presenting a prize to somebody. I don't think Archie's there, but that was the award anyway, the John Logie Baird. He won another award as well. So she was the widow of John Logie Baird, the inventor of television. She was the second wife. She was quite old at the time as well. I think she might have been in her 90s at that, even back in the 1980s. It was amazing. I never got a chance to talk to her, unfortunately. But also there, because there was two John Logie Baird awards he won, and I get them a bit mixed up actually. One was in Helensburgh, which is where John Logie Baird was born, and the other one was in Glasgow. I think the first one was in Glasgow with the tape, and there was another one in Helensburgh. This is again at the awards. Somebody who was invited was the famous Professor Rubik, as in the Rubik Cube. I got a chance to talk to him. I don't know whether he's still going around or not. And these are people from the Scottish, it wasn't the Scottish government then. was the British government. He was the Secretary of State for Scotland and a few other people. So I think he might have presented prizes as well. I'm not sure it was the same one. And this is another picture of Archie with... he was in various articles and on TV, but this is to do with the amplitude lock loop, which I'll be talking about more later. But so what I wanted to do was just to show you how this how this contour biasing thing worked very simply. I'm not actually going to show you a tape or anything like that and demos and things like he had, because I don't have anything. But what I've got is a simulation of y equals x cubed in LabView. So there's x squared and there's another x, so this gives us x cubed. And what I'm doing now is I've got two signals. One, it's baseband frequency, anything up to 20 kilohertz, and I'm adding an AC bias signal. This is AC bias. So that was what was used in nearly all recording. There was DC bias before that, which is pretty noisy. Nobody used it. So this is a high frequency signal that is added. It's just a summation. It could be anything from 40 kilohertz upwards. Again, I'm not an expert, so I couldn't give you exact figures. But I read online it could be 40 kilohertz, so anything outside the audio range. And it's much higher in amplitude. And Archie explains in the algebra, it comes out in the algebra why that has to be the case. And I can show you in a simulation rather than doing this. And then there's a filter after this is like playback, and there is a low pass filter. And this filtered output is really like what you get on tape. So first of all, if you don't put any bias on at all, I'm going to turn the AC bias off. Just put 0 AC bias. And if you put a sine wave in here, there's 2 kilohertz and so on, you can see you get this enormous distortion coming out on the tape. And Archie was said that's due to your y equals x cubed characteristic of the tape, or something like that. I haven't put saturation in here, of course. That's another matter. You can't really run into saturation anyway, but obviously there's a lot of distortion and that doesn't work. So how does AC bias work? Well, I've made the AC bias, this is signal's got amplitude 1, and I've added AC bias, which has got amplitude 10, and let's put it at 40 kilohertz, which is outside the audible range. You get this at the receiving end then, but you have to, because there's a term of 40 kilohertz, you then put a low pass filter and you see on it, and you see it's perfectly linear. That's AC bias. Very simple. It's a cubic characteristic, and you linearize it by adding a high frequency signal. How does it work? Well, it's a bit like it used to be called a dither signal in control systems. That's why maybe Archie came up with it, because he was a control person originally. But it's the same mathematically. I'm not going to do this here, but if you add A cos omega 1t plus B cos omega 2t and you cube them, you can do an angle reduction, and then if you can show that if B is much greater than A, you can recover the original signal. It's as simple as that. Now, what's wrong with this, as Archie would point out, is that the AC bias, although it's a very high frequency, is 10 times the frequency of the original signal. Now, if it's not, I can show you what's happening. Let's just make it the same amplitude, and you can see straight away it doesn't work. You get distortion. So it has to be much higher in amplitude. You can just increase it slightly. Even there, it's beginning to get a bit more linear, isn't it? And it's more. I haven't got a spectrum analyzer in front of me. I actually used to sit with the spectrum analyzer on all day long, measuring, when things would the levels of distortion. But you can see that it's very distorted when it's just a low amplitude, and it comes out in the algebra that the amplitude must be high relative to the other signal. But the trouble with this is that it uses the dynamic range. It uses all this range of the tape, which should be used for signal. It's got this in, even though it's at a different frequency, it's using up this massive range, so the signal goes into saturation much quicker. This is what Archie told me anyway. So all he did was he put a shaping circuit in before the nonlinearity. I haven't obviously got that here, to linearize the X cube. There's not much point in doing that because it comes out as obviously as a straight line. He used to get annoyed when people called it, oh, what you're doing is pre-distortion. But call it what you like, that's what he did. You would get different results from different tapes sometimes. They weren't always exactly the same. He used to sit there with the CD player. He'd have some of the earliest CDs that were done, at high quality, and he'd switch between the two, and we used to do listening tests to see which was better. The noise was ridiculously low in his system compared with a normal cassette. It was basically hardly you can hear anything at all. It was like a CD. He had actually done that. The noise floor, of course, I don't think would have been, as I remember, would have been as low as a CD, because the CD was 16 bits, 6 bits per 6 dB per bit. That's 96 dB down. It's actually used to remind me for a CD. So I don't think we were getting that with the analog system. But the level of the white noise, the hissing, had all gone. There was no need for any Dolbys or anything like that. That was out the window. You did need to, if anything, turn the tone down a little bit in the high frequencies. And this news shot right around the world. I actually went off to a conference. There's a paper on contour biasing if you want to read it. I couldn't get hold of it because not being at a university anymore, I don't have access to the library. Everything's under lock and key in terms of you have to pay to get publications, of course, through the IEEE or IET and IEEE. But the newspapers were at his conference and everything, and I was left to answer the phone, basically. And I was getting all these phone calls from all around the world, including New Zealand, which was quite interesting. And I remember having to do these radio shows, like as they wanted my comments, because I don't know how they got hold of my name, but my name was mentioned on it. And, I said to them I wasn't, the expert in the area, but, I had to appear as if I knew what I was talking about. But there it is, that's contour biasing. For people out there, yes, it worked. There are people around who may still have his tapes. The thing about his tapes were you could play them back on a normal tape recorder. Yes, you needed his special circuitry to record them, but you could play them back on any normal tape recorder. And many people in Paisley had these tapes, which he would give them. He didn't sort of post them out to just about anybody. I think he should have done, but he didn't. So obviously hi-fi people can be very critical, but really I think I've got a reasonably good ear. It was night and day, as his brothers would often say, his tapes. So there it is. That's how AC bias works. It's like a dither signal. The characteristics of a magnetic tape, it's not a hysteresis loop, it's just a cubic loop. Often hysteresis loops are shown. Now, hysteresis actually would explain is the mechanism of which the flux is recorded, I think, I seem to remember. But when you're actually doing the recording, it appears as a cubic function. And I actually had a low load of people from around here, Philips from Holland, the digital audio tape people around to demonstrate to them. They were quite sceptical when he told them, but again, once they'd seen it all, they wanted him to record. He was normally recording sine waves. I don't think they were interested in the music, but engineers record sine waves and then play them back and look at the spectrum and so on. But this is a long time ago. Cassette tapes are all but obsolete now, I say, But of course, that's not quite true because they made a bit of a comeback in recent times. But I thought I'd mention that anyway, just from a historical point of view. And I'll be coming back to Archie in another talk. Thank you very much. Bye-bye.